Yes. Okay, hello. Today we're going to talk a little bit about service workers. They are a nifty little thing that came in 2014, I think, but they are going to revolutionize the way we will program web apps. But for starters, let's talk a little bit about JavaScript. So when someone asks you what is JavaScript, you can tell him that that's a simultaneous, non-blocking, synchronous, concurrent language, and everybody is like, what? So what does that actually mean? That means that we have asynchronous, not parallel programming, meaning we have only single thread. I think everybody gets that. That is achieved through event loop, and there's a talk by Robert Phillips about event loop. I won't get too much into that, but you can check it out here. It has a bunch of APIs. It has a call stack, callback queue, and a bunch of other stuff that is not shown in this image. So we know that JavaScript is run in V8 engine, and V8 has only heap and a stack. So that's it. He doesn't know anything about asynchronous. He only knows how to handle objects on heap and a stack. Browsers implement web APIs, which are interfaces to communicate with DOM, to do AJAX calls with XHR, and set timeout, and a bunch of other stuff. And that is the part where we get to the async stuff. So JS has an event loop and a callback queue. So what does this mean? When we call a function in JS, it is filling our stack with functions that are being called. These functions can communicate with web APIs, which will then handle our asynchronous stuff. So let's say we set a timeout on something. It will be pushed to our callback queue, and event loop will eventually put it on a stack. The main function for event loop is that it checks the call stack, and if it's empty, then it will take first thing from a callback queue and put it in a stack. That okay with everybody? So the problem here is, let's say you have some big computational function that takes like half a second. That means for half a second, your event loop is blocked and everything in callback queue is blocked because it cannot do parallel stuff. It's async but not parallel. Do we get this? Okay. So a little improvement was brought with JS workers. There are simple scripts that are actually run on a separate thread. They cannot communicate with DOM or window object or anything like that. They can only post messages. So you can basically put your computational things into JS worker. When it's done, it will post message to your main thread, and the main thread can handle it. They have a requirement. So SSL is basic requirement for any type of worker, including JS worker. And for Mac users, this is a simple instruction how to set it up. It's not too hard, so you can do it. JS workers are supported on almost every modern browser, with the exception of EA, of course, and Opera Mini. So let's get to the service workers finally. So they are a type of JS workers. They're also run on a separate thread, but the main thing that's different from the web workers is that they have scoped access. That means you can register them at some URL, some domain, like let's say for instance facebook.com. Then it can access only things that are from facebook.com. It can go to Google and get things from there. It can only access from facebook.com. Is that okay? Cool. Okay, they remain installed after tab is closed. They will persist throughout multiple sessions. So they are always in your background in your browser. The web workers, they are removed the moment after the tab is closed. Cool. So we have a worker that is in our background, and it can do a lot of stuff, and it is always there. So one of many things that service workers are used is offline first approach, because we'll see later it can access cache, and it can intercept fetch requests and all sorts of other stuff. These are some of lifecycle events. So first, service worker is installed and it triggers an install event, then it is activated. Then it can intercept fetch events. That's basically every request to some resource. So Ajax, basic static scripts, I don't know, images, all sorts of stuff can be intercepted. They can do background things, which is a nifty little thing. If you are doing post requests and you're offline, you can intercept those requests, you can save them, and when you get the network, you can push them to the server. And
does the user have to approve anything, or?
No. Basically, this is like a middleman between your code in browser and your server. You have a service worker that can listen to these events, but you have to install it. That's why you have scoped access. You can only place them on your
But it's
server.
still there when you close the page.
Yeah, but you only for your page. You can't install your service worker and then intercept calls from some other server.
Okay, but you could, let's say, drain the battery even when the page is closed.
It's not active like that. Mm-hmm. Only if you have when your page is not currently active. Mm-hmm. Only some stuff will register, like push notifications and background syncs. Those are only two events that will be activated while your page is not active. So basically on background sync, you can pull some other stuff to get more content to deliver your users, or you can intercept push notifications and let them have a different format for displaying. That's we'll get into that a little bit later. But yeah, it doesn't take too much better because Chrome handles it for you. And yeah, I mentioned push notifications, so you can also intercept them. Come on. Okay, so this is basic flow of service workers lifecycle. It is being installed, and if it has an error, it won't be installed. It will just display that error, and that's it. After the install event, we have activation, and activation event is called every time you start your tab. So you can register when user has actually came to your page. After activation, it goes to idle, and it waits for specific events, like posting a message from main thread, or fetch event, or background sync, or push notification. After that, it can be terminated, or it can go back to idle. So a little disclaimer for starters: service workers aren't completely implemented on all browsers. Currently, only Chrome, Firefox, and Opera support it. Edge has it in a development phase, so they're currently developing it, and Safari has said that they will implement it in the next 5 years. They put it in their 5-year plan, so basically they will come. Why? The reason why we should implement them now, because we can do a lot of stuff and we can improve user experience on these current browsers, but when other browsers come, they will have it already. So let's talk about little main advantages. We can do caching. Separate thread can communicate with local storage and cache and IndexedDB and all sorts of other stuff. It can not only communicate with the visual part of the page. So that works even with default browser cache. If you don't, Firefox had some problems with default cache, but you can include polyfill and everything will work. We can implement offline because we can intercept fetch requests, we can intercept get requests, and we can cache them. So if we're offline, we can deliver to user that content. He will not get a nifty little dinosaur that will jump. He will get actual page, and he won't even register that he is offline unless we show it to him. That's really good for like when you're taking a trip and you go through a tunnel, you lose your connection, but you won't lose the page, you will remain active on it. And of course we can build progressive web apps with that. We can reduce the load speed of page because we can serve content directly from cache. We don't have to go to server. We can set push notifications, decide what to do on those. The nifty little thing is like, I think that Facebook has it implemented. If you get a push notification from their server, it will be displayed, and they will go to their server directly and get that message. Like, for instance, I send a message to someone in chat, it will get that request, and even if I'm offline, when I click that notification, I will get that content. I won't get blank page or you have no connection. I will get that page even if I'm offline. You can do background things. As I said, you can save post requests and trigger them later when you have network. So I think it's time to get in some little code. Basically, I've created a little app that is about client requests. So when we get a request, we get some, I think I put 5 of them to pull from server. And that's it, that's the whole app. So when we get to the network, we see we have a lot of pages and everything is loaded, and it takes some time. I mean, we have almost a second to load from a local app. Okay, so what do we need to do to register our service worker? Can you see this? I think this is a little better. So we need to install our worker, and I have created a little live templates to ease this for me, and I have implemented a special class for this. So you only need to get your worker. For me, it's in service workers worker.js, and it needs to register. What's going on in the background here? So we check if there is a service worker in Navigator. So we check does our browser support service worker, and if it does, it will register a file path that we have provided him. That's our worker that will do stuff on the second thread, and that's basically it. That's all we need to do here. And what I did here, I've said to my code that I want to include this file as a service worker on our page. So when I go to the application and service workers, when I restart, I will get an installation of my worker. That's it. From your client code side, you have only this. Everything that will happen further is in your service worker file, which will do everything behind the scenes. So there is no extra loading because it will load only once, right? And everything else that will be done on a separate thread. Okay, that's it for now. We are going to continue now with our presentation. So we have seen how easy it is to install a service worker. It's now functional on our separate thread, and it can do a lot of. We can register to events and all sorts of things, but I'll skip that because if we set an event listener, it's not so cool. So what can you do with that? You can do offline approaches, and you have some different types how to implement offline approaches, like when to actually store resources. You can install them on install event as a dependency, meaning that if you don't have that file or fetch request fails, you won't get a service worker. We can install them as no dependency, try to get them and cache them if they're here or not. An activation, an user interaction, network response. We can stale while revalidate. That's a cool stuff. I'll show you that in code later. We can revalidate with cache fallback. That's similar with stale, and we can intercept push messages and do background things. Those are when to store resources, and we can choose how to respond to requests. So we can get them only from cache, we can get them only from network, which is a default behavior. We can get them from cache, but if they don't have it to cache, serve them from network. We can do cache network race, whichever comes first, we'll get from that. We can do network falling to cache. We can cache then network. We can do a generic fallback. Then all these approaches are really are explained really good in this link. Jake Archibald is one of the guys that takes a lot of stuff and implements them around service worker and offline approach first. So if you're not following him, just follow him. He has a lot of good stuff. So all those stuff can be implemented, and you always have a bunch of code, and you can use that, but it's not really good to do it like that, because you always copy some code, and it's a lot to request from some developers to implement this stuff from the beginning, and we are just reusing it. So we build the Gordian service workers, which is a custom-made architecture. It is mostly based on cache. It has support for all lifecycle events, and this is some of the basic. This is how it works. So we had some registration code that I showed earlier. It only registers to some worker. That's it. So in our architecture, we have 5 interfaces that are based on lifecycle events, and we have implementations of how resources are stored and how to respond to requests. This all is done, and everything you need to do is just give them a route to the file. So if you want to store a specific JS file, you just need to get him a route to that file, and it will be done. That's all that is required for you. And this way we accomplish that we can install service workers on any page without any trouble, and we just need to tell them, okay, I want these files in cache and I want them served like this, and that's it.
When you say it's saved per domain,
yeah,
so can you specify like 10 domains?
No, only when
so
you.
If I have 2 sites, I can't cache between them.
No, it's only per your main scope. So if you're using like I will.
And subdomains?
No, they're registered as a different domain. But there's a little workaround for getting cache and saving it. I mean, for instance, when I say it has scope domain, that means you can't trigger a fetch event in JS for a file that is not on your domain. But you can register to a fetch event. When it gets a response, you can cache that response. And you can serve them a response for that specific URL without actually making the fetch request further on.
Could you do like, okay, come to thegordian.com, and you have a service worker that caches all images.
Okay.
And all the images are on static.
Yeah, that's exactly the.
And you have somewhere else, but the images are served through static.
Yeah, that's the part that I said.
Work.
You can make a workaround around that. It will get a fetch. It will fetch normally, and after it fetches, it will be put to cache. And the next request will go, okay, do I have it in cache? Yes, here it is.
Okay, but is it dependent on the address bar, or does it check per request? Like for
No, it's regarded to the base path of the worker. So you need to put your worker in your base route.
Okay, but so if the page is deghq.com,
okay,
and the image is thegordian.com/ypg.
Yeah, you cannot make direct fetch requests to thegordian.com, but you can register to a listener to the fetch request response, and after it comes, you will cache.
It works.
Yeah, it works. you will cache the response from that page, and when you make a second fetch request to that page, you will intercept that event, and it won't even go to server. You will just serve it from your cache.
Does it take? So if we have so it's basically browser.
Yeah, it's all
does
browser.
it take incognito and non-incognito like separate things or the same thing?
Yeah, incognito is not
Like
registering. Yeah. So let's go back to code now. So let's check again what we have here. In our main JS file, we have registered a service worker, and here we have a yap.log. It's our base, and we say to him, okay, go into service worker and go to worker.js, and it can fetch anything that is under yap.log service workers. Cool. So in our worker, we have a service worker live template, which needs an import script, which is service workers static.js.com. JS. Okay, this script is the main script that has all declaration of our worker types. So it has how we will store resources and everything else. Our base root is block service workers, and we will get with a cache version 1. So now we have our worker installed, and we can register a different type of workers, and here are all that we have. For instance, let's say that I mentioned stale while revalidate. This is one of my favorites because it works on a very specific method. It will serve you content from cache, always first from cache, but it will make a background request to the resource and it will cache it then. So you will always get the newest content on your second load. But this is actually pretty good because let's say you have some JS files and you don't make a lot of changes to them. You will get those files directly from cache. You won't have to make a service. You won't have to get it from server, and it will be pushed to the site in matters of milliseconds. That's it. And in the background on a separate thread, you don't have it blocked on your page. You will actually go for the new content, and the next time user refreshes, he will get that new page. So let's say, let me check what do we have here on our network. Let's give it a app.js. I'll just copy this link and I'll give it here. So the next time I load my page, new service worker is going to be installed with this new code, and it will go to activation and it will save to cache this request. Okay, let's see how that actually looks like. So when I refresh my page, we get a installation event. This is done by browser. He will check if there is any byte change to the worker.js, and if there is, he will install that. And usually it is waiting to activate, and it will automatically activate after you close your current tab and open it again. But in our architecture, this is not good, because if you have some live changes, we'll have to wait, we'll have to close tab, refresh. So we have actually implemented this skip waiting, and on next request, it will check if you have a service worker waiting, just activate him, because we want that behavior. Okay, and if we go to our page, we will check where app.js is. Okay, I've seen it here. Okay, now here is our app.js. It is served from service worker, And if we scroll a little bit down here, we have this icon, this cog that is saying actually that this is content that is get from our service worker. This is done on a separate thread. It is only shown here, but it is not blocking to our main thread. Okay, I got my content first now because I had to go to the main. I had to do a fetch request, and when I refresh it again, I get a load reduction. It was over 100 milliseconds, now it's only 53. And it is loaded from cache directly now. And if I go to application and check my cache storage, I get cache 1, and I can see that I have cached my app.js. Okay, this is good, but you can tell your browser to cache JS files, and it will be served from cache. That's basic behavior that we all use. Okay, what can we do further? Well, specific links are okay, but let's say we have some API calls that we want to cache because they are all GET requests, right? I don't know. Let's say we have some time checking app, weather checking app that needs some weather, and we don't want to. We want to serve that content to user, but we don't know which exact routes we're going to have. And you cannot add those to worker every time you add a new feature to your API, but you can say you can do this with regular expression. I mean, if you know where something will be, you can get that. So if we check here, when I do a fetch request, it actually makes a call to our sort of API. It goes to /requests/something, and I can say this. I can pass to my worker a JS regex, which will then check if our route matches that. So if I do requests and just escape it again, now everything that has a request in it, it will be cached. And this is stale value validate, so it will always be served from cache first, then it will go to the back and do it. Okay, let's install new worker. It is skip waiting. So we're going here, and now when I do a fetch request, it is putting it to cache. I'll do it as many times I have it. Okay, and you can see that every single time it has gotten a response from service worker. But since this is first time we are getting those files, it is making the actual request to the server. And when we load our page again, I'll just change here. You can see that I got my response in 4 milliseconds. This is served from cache. And in the background, on the separate thread, we can see that it actually went to the server and got the response, and those are new data. Cool. For me, this is really great because we can make page requests a lot faster. Because
can you get both of them in your code?
How do you mean both?
So you get the cache version, put it on the page.
Okay.
And when the background version comes, put that.
Yes, that requires both. Everything I'm showing today is done on service worker side, but you can always do get me from cache on my page.
Put it in instantly.
Put it in instantly, and then get me request, and I will put it. I'll change it on the side. That can be done, but this is all on service worker side, and it's mainly there. So you don't have to change your code. You can just include service workers, and everything will function as it is.
Yeah, but like for real time.
Yeah, for real time, you can do it for user experience.
Yeah.
You will get content. You will show them a little load.
No loading, just data.
Yeah, you can do that, and that's no problem. So this is great. I really love this approach because you always get the content there. There are a lot of other workers, like let's register a worker that will make a cache, that will make a request every time to the page, but after the response comes, it will cache it. That's pretty good for stuff that you need always in news, like chat messages. You don't want to get your new message on your second load. You want to get it instantly. But if you're online, you'll have it in cache. That's pretty good, also good. So basically, that's what this worker does. And it also accepts regular expressions and all sorts of things. So let's actually now make something cool. Let's check what can be cached. Okay, so we can make some standard stuff like let's take everything that ends with JS or CSS or JPEG or PNG or JPEG, and that's it. You've just cached your all JS files, your all CSS files, your images, and stuff like that. That's it. You need one line of code. And when we refresh here, we will get new worker. We'll refresh once again, allow all of that to be cached. And you see we get all of this stuff from service worker now. So when we started, I said we have around 1 second load time. Currently we are under 800 milliseconds, and this can also be improved. So let's check what
happens if you put everything.
That's the next step. You can that's what got me into this. You can serve static content from cache. That's normal stuff. We do it all the time. But API calls and GET requests, that can also be cached. So you can basically cache your base URL, because why not? And when I just need to install a new worker. This is actually the process that is the most it can get on your nerves, because every time you make a change, you need to install a new service worker, load another time, and let it go to cache. But you can put your page into service worker, so you will get it in 16 milliseconds.
How many?
16. It came down from 250 milliseconds, I think it was last time, to 16 milliseconds. And you're down to what? Nothing, basically. You can see these requests, they are so small and they make a lot of difference. This is actually really simple project, but I have put it on several big projects, and we have optimized the page load 500 to 600 times. No, not times, percent, sorry. 6 or 7 times it was faster. It came down from 7 seconds to 1 or under 1 second. And actually I have one more example that I want to show. This is pretty much all straightforward. You can put your things to cache and you will serve them on this or that way. Yeah, I forgot. I didn't show you a service worker, this file that we include. It actually has all the definitions, and most of them are based on Jake Archibald's link that I showed earlier. He has a lot of explanation there with images that also show you this is load first, this is second, blah blah. You should check that all of that later. And I will give you a link to this file actually, so you can go through it and just take a look what is there, because this mainly depends on what you need. It's not some global behavior. We can do some stuff globally. Let's say several images from cache if we have them, because images are not changed and stuff like that. But other stuff are project based. So if you need some API requests cached, you will do it like that. the thing I wanted to show you is actually our project that we did for motion sensor. And if you check, we have a service worker installed, right? Now I'm going to do something that most developers never do when they develop. I'm going to go offline. Okay, cool. And this is on server. And I'll just reload page and I'll get my content. So I'm offline. And I don't get a dinosaur that is running. I get...
It's different content.
No, actually the content down is the same. But this we didn't implement all offline. But we can show them that we are offline and say to them, okay, we are offline, this content is not newest, but they will get a page. You have your user experience on your page. You didn't lose them because you went offline. And they won't get nervous, I don't have network connection. Okay, I'll use your page and I'll get the last relevant data that I could get. And when they...
Is there like on connect function?
Yeah, you can do that with background sync because it will get you your online event actually, and then you can post message to your main thread.
Yeah, but can you detect when you get online?
Yeah.
Like if you
yeah.
just without a refresh.
Yeah. Background syncs. That's the part we didn't get a lot into it because it takes another approach, but you can do that with background syncs. When you get online, it will get a sync event, and you can then post message to your main thread and say, okay, I'm online. I don't have to refresh it. And I don't know, this is cool for me. And that's, oh no, not from start.